are able to watch and watch later. So without further ado, let's kick off. So I'm going to go through some photos. I'm going to just share an initial photo. I'm going to talk a little bit about it and really hand it over to David and Brian to point out the issues with them, what they see went wrong, and then we'll start to talk about a little bit of what could be done differently and how to approach the resolution. So the first one, I'm starting outside the facility. These are real photos. We've protected the innocent or guilty of that, but got some delicious standing water here next to a grate, and right behind you, that you can kind of see the cement blocks on the bottom. Those are modular buildings for a cannabis cultivation grow. So I'm going to pause there. Brian, I mean, you're the architect engineer here, or architect designer here.
Right.
What concerns you about this? How does this affect you in planning?
Yeah. Well, unpaved surfaces are difficult, right? Employees are going to walk across these surfaces, so dirt gets on the shoes. In the background there, I see looks like a typical rain leader, that black hose coming down right center top, dumping water onto the ground. So in facility design, and to protect from biological, chemical, and physical contaminants, we want site design is really important, and how the building sheds water, where that water goes. Standing water, mosquitoes breed in standing water, microbial contamination breeds in standing water. Somebody's going to step in that at some point and have that on their shoes as they come into a facility. So, as we move from kind of makeshift, pop-up legacy grows into things that have to be regulated and standardized, water control, site design play a huge factor.
Yeah, thanks, Brian.
Civil engineering and all that.
Yeah, David, go ahead.
Two things out of from the food side of the world. Food often has the requirement that the buildings are dock height. The 0 over the floor is 4 foot above the paving. Often in cannabis, they don't do that, but sometimes they do. And all building slopes should be away from the building. You go out after a rain with the asphalt contractor, you see a puddle, it's got to fix it. No, all sheet drained away from the building with a slope to storm drains out there. If you can afford it, those leaders should go underground and be captured and not surface splash.
Right.
So that's just a couple of things on this particular picture.
Yeah, thanks, David. I think, the point too that I want to bring up, Brian, you and I have talked about this in a couple of places. The GMPs, good manufacturing practices, and let me just say, even if your state doesn't require it, the point that we're always trying to make in the case is that these benefit you as an operator. These are just basic best practices that make your operation work. And GMPs start when you turn off the county road. So it's not just inside, the kitchen. It's not just inside the storage area. You can't really define it that way because the risks extend as soon as you start on your property line and even down the street. So I think that's a really important point to note. And starting outside is a key issue.
David,
Any final thoughts? Yeah.
Yeah, before you jump away, let me take on the sort of obvious thing is like, why is this stepped structure here wrapped in fabric, right? Separating the gravel from that concrete paving. That's called, the technical term for that is wattle, W-A-D-D-L-E. Wattle is sort of a barricade to keep water from moving from one part of a site to another part of a site. So what's interesting about that is somebody thought about this. Somebody realized, oh, there's water on our site and we want to keep it contained and, not flowing onto this. What I'm seeing on the, what we all see is that poured concrete slab, right, on the right from the gravel area on the left. And that fabric covered piece is actually somebody designed a system to keep the water on one side from the other. So somebody had some intention here. There is some intent, and I don't want to overlook that or completely ignore the big white thing in the middle of the photo, and give somebody some credit for trying to separate it. And Maybe this photograph was taken in mid-process. Maybe all those things are yet to come, but I'm sure plenty of us have seen a sort of halted or arrested development, if you will, where, you know, good intentions never get implemented. Lots of implementation needs to happen after this photo. Yeah.
Yeah, thanks, Brian. So I'm going to stay outside for a moment here and share another one that Brian and I have talked about a bit. You know, this is maybe a more extreme case of what you saw in the previous photo, but yeah, Brian, anything you want to add, kind of parallel in the same conversation?
This one, David and I shared with David, this came across my desk as an advertising brochure. So this was an advertiser's appeal to the cannabis industry, to all of us, right? Hey, buy our Connex container, the one on the left looks like a Connex, right? The one on the right, yeah, it looks like it's prefab. But they put it down, they plopped it down in the middle of a, I don't know, moonscape with water on the ground. And, you know, imagine again, having to walk through that, up that rickety set of stairs that, you know, landing not even big enough for the door swing, right? Just let me count the ways that this is wrong, right? So all that water and that mud gets tracked into the facility. And I've fielded calls from great folks in South Africa who are like, oh, we want to do a container farm. We want to use Connex. Oh, why? Well, because, you know, one day it's legal, the next day it's not. We want to be able to pick them up and move them if we had to. So what do you mean? You want to set them down in the middle of a field? Yes, we want to just put Connex boxes down the middle of a field. So this was just after that call. This came across my desk and I shared it with David. Yeah.
Kind of serendipitous of the timing there with your call in South Africa. Yeah, and it's, I mean, the point, right, is, and I've seen this in so many other facilities too, where you mentioned the gravel parking lot at the beginning, and every vector, we as humans are the biggest risk to a cannabis facility, to any facility that's producing products that are consumed, ingested, or otherwise. And so you've really got to think about both from the standpoint of what are your employees wearing to work? You know, are they wearing their street clothes and bringing them in? Where were they beforehand? Your contractors, the consultants that come in, those are some of your biggest risks.
Just the FedEx delivery that comes to bring, the truck that delivers your consumables, your cocoa coir, your plastic pots, your air pots, your salts. How do they get to your facility? What is that vehicle driving in? What's your parking?
Yep.
David Dixon mentioned dock height, right? This is, I mean, there's a great example.
I'm going to jump to, that slide. Let's tee that up. Go ahead.
So, you know, this is one that I like because so bottom of that door is a horizontal sort of lighter gray bar with some lines in it. That's an exterior mounted dock leveler. I like those. I like exterior mounted dock levelers because they don't create an air infiltration hazard to your sill. Think about where that rolling door lands, right? That should be a nice tight air seal. When that rolling door is closed, that's your protection against infiltration from, you know, everything outside from getting inside, right? Keep your dumpster away from this door. Don't let an open dumpster sit right next to this door so that flies can come out of it. And then as soon as you open your door, those flies just flow right in. Having an exterior dock leveler is a nice feature. So it doesn't, if folks know technically how dock levers work, the traditional ones create an air infiltration hazard to a tightly sealed facility.
And this is an example of a dock height at this point. This would not, most likely is not a depressed dock where your facility is at grade and you go down into that depressive hole down there. So this could be sloped away from the building. You'll notice the safety feature of a dock lock and the light to tell the driver that the dock lock is actually engaged in the T-bar. That's a nice touch. And you've got a pretty high-end dock seal for air infiltration. This could even be a refrigerated dock behind that door. Right. Could be with that style of dock. So somebody's taking good care to detail this out correctly.
Yeah, anybody wanting to have their ingredients for food manufactured delivered, right? You think if you're making food ingredients with butter and eggs and milk, you don't want a lot of things flying into that door once you open it up. And so that whole apparatus on the left, the right, and over the top will reach out and grab the back of your delivery truck and seal it. It's a really nice feature.
Yeah. And so we're kind of, this is a good example of when things go right, how to do it correctly.
Right.
But let me also add to the point, where I've seen things go wrong on this good intention is in the facility design as a whole, and the way employees go throughout the facility throughout the day. So you have changing rooms in the front, you're putting on, work issued PPE and uniforms, right? And then you've got the warehouse area, and you've got folks that are not dedicated to the warehouse that are coming and going, grabbing stuff. They're actually coming outside. So you went through all that effort to make sure that your employees are not being the vector of cross-contamination by putting them in their own their own uniforms on the inside, and then you're throwing them back outside through the back door, and you're leaving this dock door wide open, and you're not having a way to quarantine and decon your products and approve them before you bring them into, whether it's your packaging room or whatever it is, your everything from your fertigation supplies to your raw materials, oil, etc. So those are things where good intentions can still have unintended consequences on the operational side that you really have to be mindful of.
Right.
Yeah, I don't know, David, if you want to add anything. This really comes back to, Brian, I like your point at the beginning, the biological, chemical, and physical risk, BCP. Those are your 3 risk points that you have to look at. Those are your 3 hazards. And that starts getting into food safety and basic risk assessments and understanding what, for each ingredient, for each step in your process, what those risks are and how you're going to control them.
This particular dock will protect against, as much as possible, both rodents and flying insects.
Yep.
Mm-hmm. Yep. That's awesome. Thank you. So I want to go to this slide back one as well, because this is something that, Brian, you really taught me, and I didn't even think about this. But again, back to the whole point of the facility starts, GMP start at your property line. So
yeah.
What's wrong with this? What looks like some nice landscaping?
Exactly, right? So I in turn learned this from growers that I've worked with, but the hemlock plant is a very popular shrub throughout the United States. Certainly up here in the Northeast and in the Mid-Atlantic, hemlock is a popular landscaping shrub. It also happens to be a harbinger of a particular mite that will infect a cannabis, that will transfer easily to a cannabis plant. And so when you're looking at, when you're doing site selection and facility selection, if you're looking to inhabit, an existing building, or you're looking at a new site, or you're doing landscaping, make sure that your landscaping never grows so big and goes unattended that it grows over your walkways, so that when your employees move past various plants, they're not inadvertently carrying unwanted stuff into your facility. I've gone so far as to have the entire landscaping changed because it was hemlock all over the property. And the customer had it all removed and had different landscaping products put into it. This is I don't know that that's a hemlock tree, so don't quote me here, or somebody who can see the particular needle structure on that conifer. It's not, but the point is that you want to control and manage the landscape so you're not bringing unintended consequences in.
Yeah. Thanks, Brian.
And the closeness of the landscaping to the building is a problem. Usually you want to have at least 6 feet to any plantings away from your wall. And there's usually lists of don't plant these near your facility. A lot of fruiting trees and specific issues that are harbingers of specific pests.
Mm-hmm.
And I'll pick up on what David Dixon just put down. So if you had a good 6-foot buffer and, as we mentioned earlier, positive slope away from your building, one of the things to my eyes as an architect, I can see that that's basically what we call a PEMB in the background, a pre-engineered metal building. I can see that because of the roof slope. I can see it because of the detail at the eave, the type of gutter line that's coming down. And if you look down behind the landscaping on the left-hand side, you'll see a little bit of exposed concrete, and you can see the siding hanging out over that. Mm-hmm. Anybody on this call who's doing site selection or considering putting up a pre-engineered metal building, one of the reasons for Dixon's comment there about keeping the landscaping back is that is a notoriously poor place. The detail of the way that those buildings are manufactured, they're generally intended for equipment storage. They're not drug manufacturing buildings. And so that gap, there's often an air gap or a very poor type of seal to keep the air and the rodents and the insects out of your buildings. Right around, we call that the skirt, right, of the building. And that's a really important place to look for damage and leaks and possible infiltrations.
Yeah, the facility envelope and the tightness of it, the air tight, any gaps, leaks, holes, any opportunities where those intersections exist. And I think, yeah, David, you and Brian both pointed out really good points about, forget the hemlock or, whether it's a hemlock or not. I'll have one of my ecology friends, challenge, botanists challenge us on that. But yeah, going back to the landscaping so close and proximal to the building, and whether it's actual landscaping or whether it's weeds and debris and grass that's just growing, easy opportunities for pests, field mice, rats, other bugs to just develop and harbor. And that's why you have an integrated pest management program. You've got your pest control, you got your pest boxes out there, but they can still get around that. And the more places you have for them to hide, there's a door right around the corner with a small air gap, really easy opportunity for egress. And that's not just for cultivation, that's just as important for food processing, drug manufacturing, et cetera. So these are really, easy afterthoughts where folks don't think about it. You walk past it every day, especially once you're operating. But you've got to maintain all this too, and make sure it's, staying maintained and not getting out of control, whether it's weeds or having, bushes and landscaping so close. I'll move on to the next photo. So this is another good example of, during the design process, making sure that you're actually thinking through what your room is intended to be used for, and realizing later during your mid-construction that change your mind. Oh, you want to actually produce food in here and you need a sink and you didn't actually run the plumbing beforehand. So hold on. What's the impact here? And we haven't even gotten into the interior and the cleanability of the surfaces, just putting plumbing and fixtures on the exterior of the walls. You want to have those things trenched or behind the walls. So this is an impact of, really what happens with poor planning. I don't know if David or Brian, you have anything to add to that, or examples where you've seen something similar, unintended.
We have a lot of renovations in this sector, and getting knowledge of what is going on under slab and how you need to worry about slopes and how you need to worry about connecting to it, whether you trench that as they've done here, or whether you take up that entire slab. That usually requires hours of conversation and estimating. Sometimes you don't know, you have to run cameras down under slab drainage. There's a lot of things, but understanding what's going on under slab is one of your first challenges in looking at a building that you might want to renovate.
And it makes this image all the more painful to look at, right? Because I see on the right-hand side of the door, I see a key fob strike of electronic, right? So this job got as far down as already having the jams installed and the electronic gear installed. And that's why it's so painful to look at a slab being cut up. You realize that those two things are completely incongruous, right? You shouldn't have open floor cuts putting in drainage when you've already had finished electric installed. And I can see the shiny reflective nature of the inside panels, right? They were anticipating some sort of cleanable surfaces in there. Again, not great to have to cut it up, bring in, and that's new sand. That looks like, somebody brought in that sand to fill back in that hole. Oy.
Yeah, it's a major bummer, for lack of a better word. I mean, and that, I want to just emphasize the challenge that I always see, and there's no perfect answer, right? You don't have all your answers at the initial outset. In a perfect world, you've got it all figured out and you just plot everything and overlay it. But there's always changes mid-process. There's always unintended consequences and minor impacts. And the further you get along in the design phase, the more expensive and costly they are. And once you get to construction, it's a whole nother ballpark, of course, too, as we're seeing here. But it's really important to, think from your business plan perspective, and just think from, what do you want to produce and where? What are you willing to do? And what are you willing to say we're not going to do, and keep it off the table? Because when you make those seemingly minor changes, we want to do, a beverage line, or we're going to do chocolates and gummies, or, we're just going to do chocolates, or we're not going to do any of that. This has real implications that drainage, how are you cleaning your product? How are you doing clean in place? You spraying things, you doing spray foam, spray down? Do you have a drain in there? If you didn't think about that beforehand and work with your architects on it, Brian and his team will not have put a drain in there. And another example of how you get to this situation late in the game.
Right.
Any last thoughts, or I'll move on to the next slide for you guys.
Yes, please.
All right, this is one of I know David's exciting slides, and Brian yourself talking about the interstitial space. So what the heck is going on in here?
Well, this occurs often in renovations, or if it's a new build, it's a mistake. But people are buying buildings and they might have 24-foot clear to structure. They might have 26. Some of the newer ones have 30-foot clear to structure sometimes. But by the time you get everything designed and what's going on in the floor below, you don't think so much about how much height you really need to do a good interstitial space.
Right.
And my rule of thumb is if you have 3 foot clear to the beam, you have a little bit more to the trusses. But if you're 3 foot clear to the beam, you're already in trouble. You need about 4.5 feet to the first obstruction to run your mechanical, electrical, and fire protection systems in that interstitial space. You also need to ventilate it and heat it sometimes, and to avoid moisture and condensation in that interstitial space. But that one's hard to operate in, and could very much a safety hazard.
I'll pick that one up, David, from something from a cannabis side. So we're looking at the roof above, the ceiling above is the building, and that white corrugated metal, what looks like the floor, is actually the ceiling of some space in which value is being created, right? Maybe it's food manufacturing below our feet here, or below our knees, more likely, or maybe it's maybe it's a grow space. When, David mentioned some building heights, 20, 26, 30 or greater. I've dealt with buildings that are purchased that are only 14-foot clear height from the slab to the and customer wants to do a 2-tiered grow in that space, right? So suddenly there's almost zero clear height above that, between the ceiling and the building above. And I take David's mantra to heart. I want almost 5 feet. I want a walkable ceiling. And the reason from a horticulture perspective is I want to avoid having roof or ceiling hatches that a laborer has to come in with a ladder, try to align the ladder as close as they can with the benches or the racks to that, because they're often the bench and the rack is not in the right place. The ladder doesn't quite line up with the roof hatch. And you remember, you've got the reason you're doing that is to change filters, right? To come up to some sort of air handling unit that needs a filter change, and you've got to come in through the grow space. That all just sucks, right? So when it comes to facility selection and site selection, look for, if you're buying a building, look for a building that has really good clear height, like an Amazon distribution center. That's perfect, right? 60 feet high, something, right? That's ideal. I'm jesting.
Well, a wise man once said, no mistakes are made in plan, all mistakes are made in section. So if you're not up in there on the whiteboard doing sections in your kickoff meeting, you probably made a mistake already. So we all think in terms of plan, and we look at general arrangement drawings, and we look at architectural floor plans, etc. But we often don't spend enough time thinking vertically.
Yeah, think about that at the site selection, because realtors always have a plan to hand you right there, right? Oh, it's this many square feet. Oh, it's got this many bathrooms. Oh, it's got this much this and that. But they only ever show you a plan. They never show you a section to let you know how high is it really to the first obstruction, which is important because the beam could be much lower than the trusses, and the sprinkler pipes are even lower than that. So all of that matters. The section of the building, understanding how high it is, how much clear space really matters. And the other thing that is, you want to look up here for any stuff that contractors leave behind, right? Crumpled up water bottles and Dunkin' Donuts cups and just junk. You got to write that into your contracts. If you don't write it in the contract and no one observes it, they'll just leave their junk behind them. Most installers, if they're not, if no one's holding their feet to the fire, they'll just leave a lot of old wire and cardboard boxes and all kinds of junk up there.
Yeah, those are really good points. I mean, I think the takeaway to emphasize is, the planning and looking at the section, right? I mean, these are a lot of considerations that when you're in a rush to get to market, or, the real estate industry at the market, finding a facility can be challenging, especially with local jurisdiction issues, host community agreements, and say the state of Massachusetts, and you may not have a lot of time to jump on a building, and you've got to make decisions fast, funding issues, but these things, I mean, do you have any advice? I'd love to hear your thoughts on. So you don't get those 24-foot ceilings. You don't get that great interstitial space. What's the long-term consequence, or what are the workarounds that you try to throw in there to make it less painful?
There's just a lot of coordination. 3D design has helped a lot in this, but you see it's got a solid beam. Sometimes that's an open truss, and you can run conduit, you can run fire protection piping through it. We can put ductwork above the roof and drop the ductwork only vertically through this interstitial space. There are about a dozen tricks when you're height constrained in your interstitial space, but it all requires planning. And it requires a level of detail in the 3D model that you probably didn't think about paying for when you hired your architect. But it's called LOD 300 for those nerds out there. But you need more information in order to coordinate this properly to allow you to do some of the workarounds.
Yeah, that I agree. Coordination is the key. Making sure that your engineers and your architects don't necessarily have to be in the same state as even your facility, but it's really good to know, do they have it in their scope that they're talking to each other? Are they sharing drawings? Are they working in a Revit model? Or are they only working in a 2D, two-dimensional plan drawings, right? So those are some questions to ask and request a high level of LOD is level of detail 300. You want a high level of coordination to high level detail, and even look at that exposed A-type light bulb in a porcelain socket ready to be smashed against somebody's head as they're moving through with a box full of filters, right? So you can understand why this is a risky sort of adventure up here.
Yeah, well said, Brian. I think you just reiterated an important point. I want to remind everybody of, these decisions have operational impacts, and preventive maintenance, filter changes. What's up here that somebody's going to have to access at some point? How are they going to access it? Which room? Where's the man door? Where's the vestibule? How are they going to get in there? And what impact is that going to have to operations? If there's live plants in the room, are you able to coordinate the timing of when your room is when you're having a room changeover? What's the impact to operations? And then that's on a good day when you have, proactive preventive maintenance. What about when things go wrong unexpectedly? And how are you going to get up there and work in that space? And what's that impact to your operations? That adds up real fast.
Yeah, that's a really good point. We think maybe these sound like, oh, here's a few, building nerds getting really geeked out on some minutia. But I think if you zoom back power of 10 or power of 20, and you look at operations over time, it is all of these little small details have enormous outsized impact on the flow. And I talked to, lead growers after lead growers, and my goal as an architect is to unburden them, right? So many growers get burdened with doing everything. They're a jack of all trade. Not only are they trying to keep the plant growing, they're trying to keep the facility together. And, a good thing to think about is to have those as separate roles, to have facility management as a separate role from horticulture. Those shouldn't be, the only reason those are lumped together is because of legacy, right? When you were fitting out your dad's 3-car garage and putting black, garbage bags over the windows and buying a Goodman 5-ton to kind of keep your HPS lights cool. Yes, you are responsible for every aspect as a grower, but in a modern facility, I think understanding that division of labor is important, both internally and as outside teams.
Yeah, good points, Brian. I think I'll to your point about, us, we can, especially you guys can really dive in deep and we can nerd out on a lot of like seemingly minutia details. And I know when we've done these with clients, sometimes it gets painful. Some folks don't have the attention span. I get it. These are very minute details, but they have real impacts. And the more we can work with folks to understand the value of that, there's kind of two sides. Is, look, let us nerd out and get these details done and tell you what to do. But then when you're like, why did you, it's going to cost more time to talk through this, and you've got to have a discussion with the engineers now, and then we've got to pull in this sanitary guy. Like, now you're just getting 7 people in a room to talk about something. That's a lot of labor, right? But it's because of these unintended consequences that we're trying to make everybody's lives easier, and it really has major operational impacts. So we really want to, make sure that folks understand the why, so that we can make everybody's lives easier.
Yep.
Awesome. I'm going to move to the next slide here. This is another fun, getting into the details, right? And the whole point here is to just show some of these, minute details that are easily overseen. You walk, you're looking straight ahead at eye level. What's the big deal here? Oh, we're talking what, an inch, 2.5, 3 inches in size. What's the issue?
This is the microbiological picture. This is where pathogens grow. They usually have food. They'll have water. This is a niche, cute little Dr. Seuss word. All that stuff is wrong. And that's where pathogens will grow.
Well, break it down, David, because there's, on the other hand, this is, otherwise I would say kind of a neat detail where you have this standoff bolt to raise, I don't know, is that the leg of a bench maybe?
It's a leg of a piece of equipment, most likely.
It's equipment leg, right? It's got this standoff, that threaded bolt keeps it up off the floor, but something went wrong at the diamond plate floor, and that corrosion that's being caused around there, that suddenly is the problem of the detail.
Yeah, there are sanitary legs that should be specified and should be bought and installed. Right. They don't look like this.
Right.
So it's usually it's a stainless, and it's a 1-point contact. Yep. It's not a flat plate. A lot of detailing that the equipment engineers are used to. But take a look at how all of your equipment sits on the floor and whether it creates a niche below it.
Yep.
Really important points. Yeah, Brian, did you have anything to add?
Well, I don't know if you have any photographs of wall penetrations, but this is a floor joint that, similar things happen when you need to bring, let's say it's an extraction lab and you need to bring piped ethanol into the room. How is that wall penetration sealed? Is it a proper gasket and a scutcheon plate that's flexible so that hose can move and doesn't rip the sealant out? All of those little details, most electricians carry, and I learned this, term from working with GMP and working with David Dixon, is good, better, best, right? We can't always afford the best solution, but you need to understand, or at least understand the trades that install these things, that's the language that they use. And so, the electrician that's doing, one day he's doing, I don't know, a commercial kitchen, or he's doing a residential house, they're going to have a bucket full of, connectors that in a, food safety environment are far below what's even called good, right? So just because they're an electrician and they're licensed doesn't mean they're carrying the correct parts that you need for your facility in their van. And the ability to specify that ahead of time could save you a lot of trouble.
Well said. Yeah, there's these just important details, and even the contractors. I want to pause for a second here and say, mindful of time, we're about 43 minutes in. If anybody has questions, feel free to throw them out there in the chat if you haven't already. We'd love to see them start building up. Anything you've got to ask, any burning questions on this slide or the ones before, start throwing them out there for us.
Sure.
But the other thing I'll say to your point, Brian, and I want to bring it back to the actual side of operational, and working with your contractors and your visitors. Again, the idea that we're the vectors, we're the risk points. Anybody that comes into your facility, especially outsiders. So what's your visitor policy, right? What's your contractor policy? Do you ensure that from a chemical hygiene standpoint, if they're declaring all chemicals they bring on site, do you know what chemicals your contractors are bringing on site? Are they doing any cleaning? I've even seen examples as innocuous as you've got an outside plumbing company come in and they're cleaning the snake. Well, where was that snake before? Were they in a hospital building?
Yeah.
Were they in a nursing home? What they're carrying major biological risks, right? You've got E. coli coming in now and that gets into your facility and then they're cleaning it. Where are they cleaning it? So making sure that you have policies that restrict those types of activities and that you know what they're bringing in, that will make a huge difference and is absolutely critical. I don't have any photos to your point, Brian, about on the wall side, but I do have a couple more that we'll share. Brian, you and I talked about this at a conference recently. What do you make of this this slide?
So yeah, you were just talking about cleaning and cleaning protocols. Everybody I talk to, this bemoans these sort of buckets or wet vacs, shop vacs that never quite get cleaned out. There's always a layer of water sitting in the bottom of that, or that mop that's sitting in there never really gets wrung out and dried and becomes a pathogen host, right? Mold develops in that. You look at this, I look at this slide and I see quarry tile, that rich red tile. Oh, beautiful, right? Well, yeah, but that's got grout between every joint. That is not a food safe environment. That's a commercial kitchen environment. Some positive things, everything's on wheels, it can be rolled around, but that floor is just, not the most egregious thing. The most egregious thing are these yellow buckets. We have to have them, but they need a place to live, right? Many customers don't anticipate they need a janitor's closet or multiple janitor's closets where these things can be properly stored and dried and all of the cleaning chemicals can be maintained. So large janitor's closets are a must-have. Sort of that's what this says to me is don't let it sit in your food area. Don't let it sit in your safe area. Let it move it out. Once you've cleaned, remove it from the area, put it back, and have a storage place where it can live.
Yeah,
Really
I'd go
important.
farther.
Go ahead, David.
Mops are bad. Squeegees, a free draining floor made with a impervious polyurethane or epoxy resinous flooring coating, not a paint, up to a quarter inch thick, but free draining to a spot drain. You use your squeegees to squeegee the water, it dries out. No mops, please no mops.
Yeah, the sanitary design, the sanitary implications, and I think going back to your point, Brian, about there's two things I want to highlight here. One, the appropriate storage. Everything has to have a home. From the maintenance, if you thought about where your tools are living,
right.
Is there a dedicated area for that in the workshop? And then what about storage of your sanitary and cleaning supplies?
Yes.
And thinking about if you have a vertical facility where you've got cultivation and you've got food production and extraction, are you separating those? Do you have mop buckets for the cultivation side? Do you have cleaning brooms and everything for the cultivation side where there's different risks and pathogens separated from your facility processing side? And then what about the janitor side on the office space, right? Those are different issues and you need different space. And like you said, yeah, you don't want these out on the floor. You need to be able to put them away. You need to be able to clean them. You need to be able to verify that they're cleaned. And then the other part is, going back to the quarry tile and the grout, this is more of a kitchen style, right? This is something you'd see in, the Cheesecake Factory, your commercial restaurants. And the challenge I've seen, and the three of us have seen it, comes back to a lot of the regulations too, right? Where some states are following more of like the food code, the restaurant code versus FSMA versus CFR for actual like industrial scale food processing. And those are two different mindsets, two different operations. Are you running a hectic 3-hour shift in a kitchen every night, or are you streamlining standardized, repeatable processes at scale? Those are two very different approaches. And I don't know, David, I think you've run into that a lot and talked about it. I'd love to see if you want to add anything to that.
Yeah, just my main soapbox is move it from a commercial kitchen mentality to a industrial manufacturing approach. It doesn't cost that much more, but it's just a different mindset. And not everybody around the table has walked through a manufacturing facility. and they're thinking kitchens, but there's all sorts of details in basically that create microbiological harborages in a kitchen design, things you can't see, things you can't swab, things you can't sanitize and verify that the sanitation step worked. Kitchen designs don't cut it. And so you need to pay attention to this shift from a kitchen mentality to a manufacturing mentality.
Semantics matter. We have adopted that so that we don't design kitchens in cannabis facilities. We design food manufacturing, and putting that on a plan can help reinforce that, making sure that people write that because there are different design standards between kitchen and food manufacturing, right? This is not Anthony Bourdain. This is not Fight Club. This is a whole different world of sanitary design and proper procedures.
Yeah. Awesome. Thanks, guys. Yeah, those are really good points. We'll do, let's do one more slide here, and then we'll wrap it up. And while we're getting ready to wrap this one up, if you've got any questions, throw it out there. Happy to have you come on stage if you're comfortable. If you want to come and ask it live and show up on camera, feel free to ping myself or the group. You can private message or throw it our way. So this is an interesting one as well, and I've seen this in a couple places, and there's a lot of good points here, with smooth cleanable surfaces on the actual walls. But when you start adding up the actual surface area here in the volume, how are you cleaning all of this? How are you going to verify that any of this is clean as soon as you get one mold spore, one pathogen? How do you actually clean that? So, I mean, Brian, I think you've given a couple good examples. I'd love to pivot to you to throw out how many issues can you see here? Yeah,
I don't know. It's hard to do show of hands here, but how many people know what that little blue box thing is in the lower left that has the hoses going to? That's a sump pump, right? I've got at least 2 of these in my basement, right? Right here in Arlington, Massachusetts. They clog up over time, right? What happens when this clogs up? You get leakage and that overflows, right? So that's a potential hazard happening. So the pipe coming out of the Quest is your condensate pipe. It's going into a little pump. When the float valve reaches, an inch, that means there's probably a ½ an inch of water in the bottom of that sump pump at all times, because it has a float valve, and there's rarely a zero tolerance in a float valve. There's typically some tolerance that it has to fill to before it kicks on. It's a little motor. It's got an electric cord coming out of the top of it. That's the black line. And then it pushes it up that other smaller diameter hose and back up and out. Who knows in this facility, whether they're collecting that humidification or not. But I look at this and I say, this is a planning decision or a financial decision that said, we know we need DHU, and Quest is a leading manufacturer of DHU equipment, but we couldn't afford to have that DHU integral with our HVAC-D equipment, right? There is equipment that could be outside of the room in which you could manage your DHU loads and your condensate loads, and not have that inside the room. So David's, where you started, I agree. Like that the Unistrut clamps, those are hard to clean. That honeycomb grid, it's a cool design, but it's really hard to get the pathogens, any kind of cleaning instrument inside of that box. It just lets junk in when you don't want junk going. And that chamfered corner in the top, stuff gets up there. There's no way to clean that out.
Yeah, usually you want to be able to at least get your hand in a sanitizing rag on top of that box, and there's not enough clearance between that and the ceiling. So you've got this uncleanable, very large surface.
Yeah. And I mean, these are real photos, right? Most of them, there's the one that Brian, you pointed out was from a magazine brochure, but this isn't suicide per se, but it's an issue that's going to be long-term. It's going to have real costs. I mean, you mentioned that means there's standing water in there and there's condensate, and those have to be inspected and cleaned periodically. How do you get up into those crevices there? Any minor gaps? That's just a harborage waiting to happen. And once it comes in, you're not getting rid of that, right? You can mitigate the bioburden, especially thinking about this as having live organic, living plants in there. Let's put on the cultivation, or this was a drying room. Once it's there, you've always got bioburden. So you're never going to get rid of it. And there's more opportunities for it to sneak in and grow and proliferate. So these are really significant impacts that have unintended consequences, and they can work in other places, but you're going to have those risks, and it's just going to up your failure rate.
Yep.
Well, any other thoughts? Any last words? I want to kind of wrap it up here and make sure we're leaving room for any Q&A. But I think the biggest point here is that we could really go on and on with these different scenarios. There's dime a dozen. There's so much we barely even touched. And these are all, kind of disparate items that all connect back to the idea of this is a holistic organism, right? We've got from your property line to your landscaping, to the grading, to how employees enter and exit, to the minute details of bolts and welds, sanitary design welds, material, the cleanability, where things are stored, how they're stored. We didn't even touch on so many things about storage and allergens and impacts and fridges and freezers and power loads, but there's a lot and it can be overwhelming. It's not a quick let's just slap this together and stand it up. It really takes a lot of thought and design. But the beautiful thing is that there are experts. There's a lot of best practices out there. There's a lot of, whether it's looking at 3A from a sanitary design standpoint, whether it's looking at UL, Underwriters Laboratories, ASTM has like 35 standards now that are consensus standards that have, gone through the process with dozens of experts, hundreds of experts. And, NCIA, where we publish blogs, coming right here. I think these are great areas. Like, come learn, apply that knowledge, and recognize what you don't know too. And, work with the folks to try to not be the smartest person in the room. Surround yourself by that cross-functional level of experts, and you can minimize the unintended consequences of, poor design and poor operations. So I just wanted to put that out there. I do have one question, it looks like here we've got. So you mentioned the BCP risk. Can you explain the differences? So I'll ask that. I'll pose that. I think I'm going to throw it to David to just maybe, if you don't mind, just describing, at a basic level there, what the difference between, give some examples of biological, chemical, and physical risks. We kind of touched upon some of them. And then I'll see if anybody else has questions.
The question was VCP? What was that?
B, as in biological, chemical, and physical. BCP.
Oh, okay. Yeah, that's has a terminology. Physical issues are anything from hair and dust and pest parts, fiberglass and insulation, metal shavings, all that's physical. Chemical is your cleaning compounds, generally, sometimes solvents, of course. And then microbiological is Salmonella, E. coli, Listeria, toxic molds, toxins. So harborages are mostly microbiological. This closed envelope, this keeping anything fibrous out of the building, that's physical. Renovations are a big problem for physical contamination because sometimes you don't have a chance to sandblast all your trusses and repaint them, There's even lead and wood and other such horror stories creeping into the cannabis sector. So that's physical and chemical and microbiological. Those are the three things that basically sanitary design tries to deal with.
Yep.
Yeah, good. Yeah, thanks, David. And I think, you mentioned a couple of good examples, like on the physical, that the facility has real impacts on, whether it's, glass and brittle plastics, the glass, the lights. Do you have a register to make sure that no glass is accidentally getting into your product line, that are exposed? Those are real physical risks. Wearing PPE, hair, beard nets, et cetera. Those are physical parts that can get into your product. Chemicals, of course, on the pesticide side, heavy metals, et cetera. So, those are risks that there's no zero. There's always a chance, and you're never going to completely eliminate it. But by, looking at every little detail, the more you can mitigate, right? The more you can reduce that risk, the better off you are. And that's both from a design and into operations. Yeah, go ahead, Brian.
Yeah, David, Vaillencourt, you and I went through a round maybe two and a half years ago on 4-foot fluorescent light bulbs, right? They have
Right.
mercury in them. That's what that's right. There's what is the powder? It's powdered mercury in these light bulbs. So your risk is that you're installing light bulbs and they break. How do you mitigate that risk? Well, obviously you try to do full LED lights. Just don't put, I think there's some states now that have banned the 4-foot fluorescent tube, and bravo to states that can do that. It's a physical risk, right? But what I learned from David was interesting, which it's that if that's what you have in your facility, you need to create an SOP around it. It doesn't mean that you're absolutely going to fail to keep mercury out of your environment. Because yes, there's a chance that could happen, but you just need how did you put it? You need a plausible explanation and an SOP that says this is our maneuver. There's never one person never changes a light bulb. There's always 2 or maybe 3 or whatever, or the ladder. You never go beyond the 4th rung of the ladder. Just as long as you have a good solid SOP, you can explain why you're operating a facility with 4-foot fluorescent light bulbs and you've got a mercury hazard.
Yep. And I think go ahead, David.
How many cannabis employees does it take to change a light bulb?
Exactly.
I'm sorry, I couldn't help myself.
Here all night, right, David? No, and the point there too, right, comes back to detectability. So you're not ignoring that's nobody's saying that's not a risk. You're declaring it as a risk. You're saying, and you're having protocols to make sure that you can detect it, so that when it happens, it's not an if, it's a when.
Right.
How are you going to control it instead of, oh, we didn't think that could happen? That's the issue. So you take your design implications, what you have to work with, and then you make SOPs, SSOPs to manage them. And I think that's the biggest operational takeaway.
You are bringing up, there's a new thing with FSMA, Food Safety Modernization Act, called the Food Safety Plan. It's different than the HACCP mindset that pre-existed FSMA. Mm-hmm. And that's where you sit around and you brainstorm what could go wrong and how do we mitigate. It's called the Food Safety Plan. It's run by experienced people who have run them before. We know many of them, but it's a critical element to have your designers in, because they can design around some of those food safety risks.
Exactly. Yeah. Well, we're at time here, so I'll give you each, if you've got any last things you want to, what's the one takeaway? If you could share what's your one biggest takeaway, if anything, and then I'll give a sneak preview. I think the FSMA program and food safety plan is a great lead off for next month, where we'll be talking about quality. But for that, Brian, last thoughts.
Yeah. Safety and design starts at site selection, and selecting a good site can contribute to success. Planning and planning from the outside in is important, in collaboration. Bringing multiple people in. Early in my career, I saw a lot of siloing, and I think I always associated siloing with the legacy market, where nobody ever wanted each person to know too much, right? Because that was a detriment to the legacy operator. You don't know you don't need to know what's going on over here. In utility company, you only need to know so much. An electrician, you only need to know so much. So try to avoid siloing and collaborate openly, and write down, say what you're going to do what you said, and then document what you did.
Well said. I couldn't agree more. David, anything you want to add to that or echo?
Oh, I just want to raise everybody's focus on what we're doing, at least in the edibles manufacturing. Most of these edibles products, except for cookies, don't have a kill step. They don't have a microbiological kill step. They're fed to consumers who may be compromised in some way, especially going to the medical side. So these products require a great bit of care, and that means your facilities that you produce them in, the equipment you buy to produce them, needs also a great bit of attention.
Yeah, well said, David. That's a super important point. I feel like I can't say enough, and I sometimes feel like I've said it enough, so I forget. So thank you for describing. These are products that people are consuming and ingesting, and a lot of them are immunocompromised, especially on the medical side. So you really have to take these risks seriously. But this has been so much fun. I'm really appreciative for both of you guys taking time out of your day. I know it's evening time over on both of your sides, but showing up to help me share the knowledge with the industry here. That's the goal, and I hope we did a good job. I hope everybody here learned something new. If you'd like to follow up with us, info@GMP Collective is how to get a hold of me over at GMP Collective. David Dixon's part of our team as well, so you can reach us there. He's got a website as well, davidcdixon.com, I believe, LLC.com. We'll have all that information up. Go ahead. And
daviddixon.com. Yep.
There you go. And then Brian and his team over at Anderson Porter at info@andersonporter.com. This stuff will be up on YouTube in short order. So if you missed it or want to watch it again or share it, stay tuned. But I really appreciate you guys and the audience for showing up. This is a lot of fun. Have a great evening.
Thanks, David. Thanks, David.
Thank you all.
See you guys.